Chapter 6. Stepwise Thinking, Algorithm and Flowchart. Sam, do you help your mother in the kitchen?
Yes, I help her.
Does your mother do things in the kitchen in a particular order, or does she do things in any order she wants?
She follows a certain order.
Take goals. Understand what stepwise thinking is. Learn about algorithm and how to write them. Understand what flowcharts are. Learn about the steps to draw flowcharts. In our day-to-day lives, we carry our certain steps in order or a sequence to perform a task and get the desired output. How does your mother make chapatis? List the steps that she follows. Rapid move. Discuss the steps you have listed with your classmates. Have others also written the same steps? Have a class discussion on the correct steps and their number. To understand how to follow a sequence or order while performing a task, let us read the given example. You want to drink coconut water. What will you do? You will follow the steps given below in a certain sequence or order. Let us see how. Step 1. Go to a shop that sells tender coconut water. 2. Ask the shopkeeper to give you 1 or 2 tender coconuts. Step 3. Make payment to the shopkeeper for the tender coconuts. Step 4. Take the tender coconut and put a straw in it. Step 5. Drink the coconut water. As you can observe, you have to follow a number of steps to complete a task. These steps have to be followed in an order. For example, you cannot drink the coconut water before going to the shop. You need to follow a systematic method to complete any task. So, you think and plan or arrange the steps in the correct order. If you change the order of steps, you will get wrong results or output. Therefore, the steps that you think and use to perform any task are a part of stepwise thinking. Stepwise thinking helps in converting complicated tasks into simple steps, predicting the possible solutions to achieve the desired goal. We will now look at some more examples. Example 1. You and your friend are going on a picnic. Your friend should have reached your house by now, but has not come yet. You are thinking of calling him or her up to find out. What steps will you follow to do the same? You might follow the given steps. Step 1. You will ask for the mobile phone from your parents. Step 2. Unlock the phone, optional. Dial the number. Step 3. Talk to your friend. Step 4. Give the mobile back to your parents. Let us look at another example. Example 2. Your principal assigned a duty to your class teacher to plan for the class picnic to the water park. What will the teacher do? The teacher will book tickets and go to the water park. But is it possible to book tickets before collecting the names of the students who would like to go? No, because the teacher does not know how many tickets he or she needs to buy. So, what should be the steps for the task? The teacher will most likely follow the given steps. Step 1. the teacher announces the picnic. Step 2. Gives permission forms to the students. Step 3. Asks students to get forms signed by their parents or guardians. Step 4. Make a list of students who give their signed forms. Step 5. Book tickets. Step 6. Inform the travel details to students and parents. Step 7. Travel to the water park. As you can observe, every activity has a sequence of steps that needs to be followed. Have you ever made things by paper folding? Let's do the given paper folding activity. Example 3. Make an origami paper boat by paper folding. Can you make the boat before folding the paper? The stepwise instructions really helped in making the boat. We use such stepwise thinking in many activities every day. Rapid move. Write the steps to prepare chocolate shake. Algorithm. We all know that a computer cannot work on its own. It needs instructions to work. You have already learnt about the I-P-O cycle. A computer works by following the step-by-step instructions from the user. To solve any problem on a computer, we have to first analyze and understand the problem or the steps to do a task. We plan the input and apply some methods in a step-by-step manner to get the desired output. This step-by-step procedure to solve any problem or carry out a task is called algorithm. Algorithm means precise rules or a set of rules that specify how to solve a problem or perform a task. So, an algorithm is a stepwise and logical solution to a problem or a task. Algorithm is always written in simple language and in a precise manner so that everyone can understand the steps. Let us learn how to write algorithms from the given example. Algorithm to brush your teeth. We brush our teeth 2 times every day. Have you observed that we follow a certain sequence? Read the given steps. Step 1. Take brush from the holder. Step 2. Open the tap of your wash basin. Step 3. Rinse your brush and turn off the tap. Step 4. Apply toothpaste on the brush. Step 5. Rinse your mouth and start brushing your teeth. Step 6. Clean the brush and rinse your mouth. Step 7. Take a tongue cleaner and clean your tongue. Step 8. Rinse your mouth again. Step 9. Finally, you get the desired result, that is, shiny white and clean teeth. Let us see another example. Algorithm to find out the percentage of total marks. Follow the given steps. Step 1. Add the marks obtained in all the subjects. Step 2. Write the total marks for which the exam was held. Step 3. Divide the marks obtained by the total number of marks. Step 4. Multiply it by 100. The result is the percentage of total marks. So, a computer works using step-by-step instructions from us. If we give wrong instructions to the computer, it will give us wrong output. The step-by-step instructions that we give to the computer is called programming. A programmer is a person who writes programs to solve a computer problem or to perform a task. Tech scoop. The concept of algorithm has existed since antiquity. Arithmetic algorithms, such as a division algorithm, were first used by ancient Babylonian mathematicians in 2500 BC. Flowchart. A flowchart can be defined as a diagrammatic representation of the problem-solving process in which decision steps are laid in a logical order. In a flowchart, operations are represented by drawing the appropriate geometrical shapes. These flowchart symbols are connected by arrows to illustrate the sequence of operations. The table given below shows a set of symbols that are used while drawing flowcharts. Symbol, name of the symbol, purpose. Start or stop. Start or stop box. This is used at the beginning and at the end of a flowchart. Process. Process box. This is used for processes or actions. For example, to add two numbers. Input or output. Input or output box. This is used to indicate input and output of a program. Decision. Decision box. This is used when one needs to choose between options and the condition of yes or no arises. Arrow symbols. Flow lines. These lines are used to show the flow of logic in a flow chart. Rules of flow charting. The rules given below are followed in flow charting. The general direction of flow in any flow chart is from top to bottom or from left to right. Arrowheads are used to indicate the flow of information or sequence of events. A flow chart should have only one start and one stop box. These steps should be arranged in sequence. Flowcharts plays a very important role in computer programming. It is a good habit to draw flowcharts as they make it easier to write computer programs. A complex problem can be divided into smaller, simpler parts and then reassembled to find the solution. Example 4. Flowchart to find the sum and average of two numbers. Rapid move. Draw a flowchart to find the cube of a number n. Working of a loop. Let us understand the concept of a loop with the help of the following example. If you want to draw a flowchart to print your name 10 times, it will look as shown in the given figure. In this flowchart, your name is printed 10 times. A counter is set up which counts the number of times a process, that is, printing of the name, has been repeated. A counter is nothing but a variable. Here, count is used as a counter. This counter is increased by 1 after each repetition. The program will check the value of the counter each time before going to the next repetition. If the value of the counter is less than 10, then and only then will the process be repeated. When the value of the counter becomes equal to or more than 10, it will exit the loop. Tech scoop. Industrial engineers Frank and Lillian Gilbreth introduced the flow process chart to the American Society of Mechanical Engineers, ASME, in the year 1921. Example 5. Flowchart to print the squares of the first 10 natural numbers. Rapid move. Draw a flowchart to print the larger of two numbers A and B. Tech summary. Stepwise thinking helps in converting complicated tasks into simple steps, predicting the possible solutions to achieve the desired goal. A computer can only work using step-by-step instructions from the user. An algorithm is a stepwise and logical solution to a problem. An algorithm is always written in a simple language and precise manner so that everyone can understand the steps. Giving the step-by-step instructions to the computer is called programming. A programmer is a person who writes programs to solve a computer problem. A flowchart is a diagrammatical representation of the steps to solve a problem. In a flowchart, symbols are connected by arrows to illustrate the sequence of operations. The general direction of flow in any flowchart is from top to bottom or from left to right. The start or stop box is used in flowcharting to indicate start and stop. The input or output box is used in a flowchart for input and output. The process box is used in flowchart for processes or actions. The decision box is used when one needs to choose between options. Flow lines are used to show the flow of logic in a flowchart.